And the name of the game is always the same. So you give subtitles to the machine, they learn to speak like actors in the movies. But the first thing you want to do is to actually open this data. You see that the format that this data is given is kind of weird. It has some weird separators. You have to understand if you have to relate something with the other. And maybe you can do statistics, like you can see, I don't know, if there are bad words, what's the average length of a sentence, what's the average turns, and you have to pay a special attention here, because I give you as an example, a couple of years ago, Microsoft has trained the chatbot on conversations from Twitter, and it turned out that most of those conversations were racist and really, really inappropriate. And the model does not have any form of common sense. So if you show them, if you show the machine racism, it will learn racism. This is why it's very important to explore the data before training the agent. But so once you have a good sense of what your data looks like, then you can do this very funny thing, which is literature review. So scientists have the good intention of publishing what they do. So if you want to solve a problem, good chances are that somebody has solved that as well for you. So first thing you do is go in the literature and research if some people did the same thing that you want to do. So if I have the corpus of movies and I want to train an agent to speak, maybe I'll look in the literature if there is somebody that did the same. And this is all a matter of reading, of understanding. Some of them even publish their code. So some of these papers come with the actual code that they use, that you can just try on your data. And after I'm convinced about what I'm going to do with this project, which model am I going to train, it is time for training. Training is typically done on GPUs. The same that you use for playing video games. This is a very good chance of asking your employer to buy you a GTX 2080. I don't think there are many other jobs where you can do that. One thing that is very important during training is to monitor how the agent is learning. So everything that you do is always a matter of measuring things. So during training, you want to know from the beginning how good was your agent on the task, how well did it predict its answer, and measure how it improves as the training progresses. And when you do that, so you have the data, you check that it's all good, you choose a model or some models to compare, you trained your models. The crucial part is the final part is the evaluation. So you have a model that can now speak, or that can predict things. You want to run a deep evaluation on this, because it's not as immediate as it seems. So let me give you an example. Say that I have a machine that predicts cancer from X-rays. And say that my data set is 100 of X-rays, and 2 of them have cancer. The other ones have not. So I can come to the hospital and say, hey, I got a model that works really, really well on your data. It predicts cancer or not with 98% accuracy. So 98% of the time, my model is right. What's inside my model? It's a model that always predicts no. So it will always say, no, this person doesn't have cancer. It does have 98% of accuracy, because on a data set of 100 patients, only 2 had cancer. If I always say no, I get a very good accuracy and a completely useless model that does not solve any problem to anybody. So the evaluation could be easy on some tasks. It may require some more advanced metrics and formulas that can capture well what you're interested into when you train a model. And normally an evaluation report is correlated with charts, lots of numbers and stats. You want to make sure that objectively that model is working good and it's solving the problem that it's supposed to. Now, I've been talking for a while. I wanted to give you an example, like a live example, that does a thing that is similar to what I was telling you before. So the people at Microsoft Research, there's a private research institution that, of course, is affiliated with Microsoft, have thought about training one of those models on Reddit. They thought it was a good idea because Reddit is very big, so they could extract 147 million interactions between users. So 107 million replies, people talking with each other. And they created a model that can read through these 147 million conversations or conversation turns. And with those, they can learn how to speak in English. So I took the liberty of doing the same and publishing a bot on Telegram. So if you go on Telegram and search for STEM Awards bot, you can actually talk with a machine that was trained by reading this huge amount of Reddit conversations. The machine is running on my laptop, and I see that some of you is already putting it to stress. I hope it doesn't catch fire. But no, in the worst case, it will just turn itself off. No worries. I just want to point out something. And if you're watching the recorded version, I'm likely to have taken this bot offline because I cannot keep my laptop on day and night, unfortunately, as much as I would love to. I would like to point out some things. Like this was kind of a game. Like I could put together this bot in an afternoon. It was not hard because most of the work is published, and I could use that. But being a data scientist in the industry requires some step forwards. So the moment you do this is where the fun begins, because not only you have to provide a model that works, you also have to reason. So now that I've implemented this model as it is described in the literature, does it solve my problem? Could it be better? Is it useful? Does it have business value? So if I go to my company, to Docebo, and say, okay, I have a bot that speaks English, will our customers like it? Will it be useful for them? Probably not. Probably they're not interested in holding a realistic English conversation. Maybe they're more interested in a machine that can recommend a course or that can answer specific questions about the things that they're learning. And so you must keep an eye on that, otherwise you get fired because you deliver things that cannot be sold. And also, it's kind of easy to take a model, train, and serve it as an example on Telegram. But in the real world, the data scientist must also talk with the product team because in the case of Docebo, we have an existing LMS platform behind. So we have to integrate artificial intelligence in the platforms. That means talking to the developers, having a grasp of how software engineering works, being able to relate, to explain to them what we're going to do so that they can take advantage of AI in the best. And also do a lot of technical work to find the best way of presenting your model to the engineering teams. And last thing, the model must scale. So we are just a couple of people now connected, and probably the bot will answer everybody. But what if I deploy this bot? I sell this bot to customers, and 1 million people start using it. Will it bear the load, or will it explode? A lot of time they explode. You have to make sure as a data scientist that doesn't happen. But so I described to you a lot of things, and it is true that in companies, often as a scientist, you are expected to be some sort of wizard that comes in and does everything. But if you listen to what I said so far, I mentioned a lot of skills, and it is not fair to think that you must have each and every of them. It is it's a good thing. It's perfectly normal if you want to go vertical on something. So there are data scientists that are very good at modeling. So they know mathematics, they read paper, they really understand, they make hypotheses on how can we build the next generation of models, how can a model learn better than the ones that were created before. This is work that can be done even just with a with a whiteboard and a marker. It doesn't necessarily need a computer. It's a lot of brain work, lots of academic work. And this doesn't only happen in universities. This also happens in companies. Like Google has Google Research, Microsoft has Microsoft Research, Salesforce has their own departments. So there is room for people that want to keep it theoretical, and their work is where it all begins. There are also people that take the work of the mathematician and make sure that it is delivered as a product. Those are the software developer kind of data scientists. So the ones that, while they have training on mathematics, they know what we're talking about, they know about neural networks and models, but they also have a very good grasp of how software engineering works. So they have a taste for structuring the code well, for writing documentation, writing tests, talking with other developers, maybe the people that are developing the front end or the back end of the application, and meet and see how can the AI part be integrated with all the rest. And this, of course, no need to say that this is essential. It brings a lot of value to a company to have a person like that. Often they think they're interested in the scientist, in the mathematician, but they're not. They want somebody that can actually do something with the science and put it in production by cooperating with the engineering teams. And speaking about this, we have two figures that are really, really important as well. Those are the data engineer and the system architect. So I mentioned before that the amount of data that we have is kind of big, like 2 megabytes per second per person big. And often our data sets do not fit our machines. So maybe the data set is so big that it doesn't fit the RAM of my computer. Maybe it doesn't even fit the hard drive of my computer, but I want to use it altogether. Or maybe I want to, for instance, this is the case for Docebo, when people talk to our conversational agent, we call it the virtual coach, we record every conversation, and we have several million conversations per month. I want to make sure that I record everything so that I can then retrain the agent, and doing so, nothing must break. So I have to keep a structured, ordered, easy to access archive of everything that is happening within my model, because data is gold. It's where it all begins. And while if I run experiments on my laptop, this is easy. I just, I write text files, I extract the zip files, and all this kind of things. If I'm working with a big load of data, there's a whole universe of tools that can be used to ingest, store, record, and access those data in ways that nothing explodes, and that everything works and that everything is fast. This is the work of the data engineer. And a friend with the data engineer is a system architect. So I mentioned before, I showed you this example of this bot that is running on Telegram, hopefully still alive, that uses a big deep learning model to answer English questions. And I mentioned that maybe this model will work today because we are a few people, but if I serve the same model to millions of clients, it may break. The system architects have the duty, the skills to make sure that this doesn't happen, to allocate the right hardware, to have entire clusters of machines cooperate, coordinate, to serve my model in a way that it can bear a very big load from the clients. And keep in mind that often mathematician and a software developer may not have a good grasp about it. So they may deliver the classical code that it works on my machine, but when I serve it to millions, it may just not work. And the last figure that I encounter when I speak with my colleagues is the analyst. So there are some scientists that are not very much in touch with the development process and the technicalities about, we say, serving the models, but rather they are very good at exploring data, producing reports, and extracting information from the big amounts of data that we have available. I call them the analysts. And so, yeah, I hope I've given a kind of a picture because, when I say I'm a data scientist, that doesn't say much. You can be a data scientist in many ways, and your day on the job may be very, very different depending on which specialization you choose. Or maybe you're good enough to expand the whole radar chart in all the directions, and in that case, congratulations. So I would say that this was my last slide, and I would like to thank you for your attention. It's been a pleasure. If you have any sort of questions, you can drop them in the Q&A panel at the right of WebEx, or otherwise, just thank you for your attention. The same video will be published on YouTube soon, and just that. Thanks. Hope to see you soon. So we have a question. Can I develop skills for data science, attending economics and finance at the university? Well, Francesco, it's full of resources out there to learn data science. I personally learned it at the university. I took a course in artificial intelligence where I was introduced to these topics. But for one thing that I've learned in the university, 10 more things I've learned online, reading papers. So I would say yes. I suggest you to visit places like Coursera or Udemy. They have very nice courses that can introduce you to data science, and you can run a machine learning experiment very, very easily. Look, I don't know if I can write. Yeah. So make sure. No, I cannot write. Sorry. Wish I could. Make sure you have a proper software development background. So you must know at least a little bit to code in Python. So I would say first thing of all, take a Python course, learn to code. And then take a look at Coursera and Udemy, follow some basic courses about machine learning or data science that will give you a good grasp, and then dive into the libraries. I recommend scikit-learn, that has a lot of tools to run a standard clean machine learning experiment. And if you want to the deep learning things, check out Torch. They have a lot of amazing and easy to follow tutorials on their website, or TensorFlow when things will get a bit more serious.